Welcome. So in this video, we are going to determine the continuity of some piecewise functions. Our first example is g of x equals 3 if x is less or equal to 0 and x squared minus 1 if x is larger than 0. Now, if we look at the first rule, 3, when x is strictly less or equal to 0, 3 is a polynomial. It is actually a special type of polynomial. It is a constant function or a constant polynomial. Now, polynomials are continuous everywhere, so that means that g is continuous when x is strictly less than 0. When x is larger than 0, g is also a polynomial, and that also means that it is continuous if x is strictly larger than 0. So the problem lies when x equals 0. But for now, we at least know that g is continuous if x is different than 0. So we need to look at the case where x equals 0 specifically. To check the continuity of g at x equals 0, we need to go through the definition. Now the definition says that a function f is continuous at x equals a if the limit of f of x as x approaches a is equal to f of a. Now that means that f of a is defined, it means that the limit exists, and it means that the limit is equal to the function value at a. Now in our case, a is 0 and the function f is the function g, so we need to check that the limit of g of x as x approaches 0 is equal to g of 0. Now first of all, let's look at g of 0. Is it defined? Well, there is a rule that says that g is 3 if we are less or equal to 0. So that means that g of 0 is defined and equals 3. Now, the next thing we need to look at is the limit of the function as we approach 0. Now, because the rule for g changes on both sides of 0, we need to look at the limit coming from the right-hand side and the limit coming from the left-hand side separately. Now, as we approach 0 coming from the left, which means when values of x are less than 0, the rule for g is 3, so we get that the limit of g coming from the left of 0 is the limit of 3, and the limit of a constant, in this case 3, is the constant itself, because as x varies, that constant remains the same. So in that case, the limit is 3. As we approach 0 coming from the right, the rule is x squared minus 1, so the limit of g in that case is the limit of x squared minus 1. We just need to replace x by 0 here. It's very simple. So we get 0 minus 1 equals minus 1. So the limit coming from the left is 3. Coming from the right, it's minus 1. Those values do not agree. So overall, the limit as we approach 0 of g of x does not exist. So that means that the function will not be continuous at 0. But we saw that it's continuous everywhere else previously. So overall, g will be continuous for all values of x except 0. In the second example, we have a piecewise function which is equal to x squared minus 4x plus a if x is less or equal to 1, and mx plus b if x is larger than 1. In that case, a, m, and b are constants, and we are asked to find a condition involving the constants a, n, m, and b, which will make g continuous everywhere. So we are looking for an equality or a relationship between a, m, and b that guarantees that g will be continuous everywhere. Now, if we look at the rules for g, they are both polynomials. So that means that when x is less than 1 or larger than 1, the function g will be continuous for sure. So no matter what the values of a, m, and b are, g will be continuous if we are not equal to 1. So what we really need to look at is what happens when x equals 1. So remember, we need to investigate the limit of g of x as x approaches 1, and it will be continuous if that limit is equal to g of 1. So first of all, let's look at what g of 1 is. So the rule in that case is x squared minus 4x plus a when x is equal to 1. So that means that g of 1 is 1 minus 4 plus a, which is equal to minus 3 plus a. Now we need to look at the limit of g of x as x approaches 1, but because the rule for x changes on both sides of 1, we need to look at the two-sided limits. So let's look at the limit as we approach 1 from the left. In that case, when we are less than 1, the rule is x squared minus 4x plus a, and in that case the limit will be 1 minus 4 plus a, which is minus 3 plus a. If we approach 1 coming from the right, the rule is mx plus b, and replacing x by 1 gives a limit which is m plus b. Now the limit as we approach 1 will exist if the two-sided limits are equal. So that means it will exist if minus 3 plus a is equal to m plus b. Now recall that minus 3 plus a is also the function value at 1. So if that condition is satisfied, we will have that the limit of g of x as x approaches 1 will be equal to g of 1. In other words, g will be continuous at 1. And because it was continuous everywhere else, that condition, minus 3 plus a equals m plus b, guarantees that g is continuous everywhere. So that's the condition we were looking for. As an example, say mx plus b is equal to x plus 2. So that means m is 1 and b is 2. Then the condition can be written as minus 3 plus a equals 1 plus 2, which means that a equals 6. So that would be the value of a if we would want to make g continuous everywhere. So in that case, g of x would be x squared minus 4x plus 6 if x is less or equal to 1, and x plus 2 if x is larger than 1.